Did you know Python can't even add 0.1 and 0.2 correctly? You don't trust me? Let me show you. If I set x value to be 0.1 and y value to be 0.2, now when I print x plus y and check if it's equal to 0.3, you expect this to print true, but this will print false. And you will see why when I really add these two numbers and print the solution. As you can see, it printed false, just like how I told you. But why it printed false? Because when I added those two numbers, it's not really 0.3. It's 0.3, but at, I don't know, at 20th position, there is some 4 at the end. Why that's happening? Because 0.1 and 0.2 can't be represented with binary numbers with 100% precision. So there's some slight error. That's why this really doesn't add up to 0.3. But there's a solution. The solution is we can use decimal module. From decimal, import decimal. Now I can set my x to be equal to decimal 0.1. But it's important that I pass it as a string. Otherwise, it won't work. It will again show the error. But now this x and y are of type decimal, and this 0.3 is float, so this will again print false. If I want to check it really, I will convert this addition into float. And now this should work correctly. Also, with these decimal numbers, you can perform any other mathematical operation, like multiplication, subtraction, and also division. As you can see, now true is printed and everything else works correctly. But what happens if I pass 1 here and I divide this with 3? As you know, this will give me infinite number of 3's. But if I want to round them or get some precision, for example, I want only the first 3 decimal points, in that case, I can use something that's called get context. And I can set get context precision to be equal to 3. Now, this set my program and every number will be rounded to 3 decimals. Also, another useful function is normalize. So, for example, if I have set that is equal to decimal 3.14000, if I print this, this will print me 3.14 and these 3 extra zeros, but I don't want them, so I can write set.normalize. This way, I will remove all the leading zeros that I don't need. As you can see, 0.333 is printed and 3.14 is printed. Get precision doesn't put extra zeros if I don't need them. If you liked this little trick, I bet you would like function optimization video as well. The link to it is on the screen now, so feel free to check it. And also, don't forget to subscribe so you don't miss the next video.